if you build anything serious in C++, testing can be, well, it can be a real beast.
It really can.
It demands a framework that's just as powerful, just as complex as C++ itself.
Right.
And that's exactly what we're looking at today. We're doing a deep dive into GoogleTest, which is, Google's C++ testing and mocking powerhouse.
And our goal here isn't just to read off a feature list. It's to really dig into their GitHub documentation and pull out the most critical nugget.
The core features, the real-world utility.
Exactly. Think of this as the fastest way to get fluent in the GoogleTest ecosystem, to understand what really makes it an industry standard.
And the first thing to know right out of the gate is that this repository isn't just one thing anymore.
That's such a key point.
It's the official merger of what used to be two separate projects, GoogleTest and Google Mock. So you're getting both the testing framework and the mocking capabilities all bundled together.
Which, that just makes immediate practical sense. On any large C++ project, you're rarely using one without the other. And if you're ready to jump in after this, the maintainers are really clear. They point you to their official docs at the GitHub Pages site, google.github.io GoogleTest.
And they recommend a starting point, right?
They do. They say to start with the GoogleTest primer. That's your essential first stop.
Okay, so let's lay the foundation then. What's the architectural DNA of this framework? Is this Google just inventing something totally new, or is it building on what we already know?
No, it's firmly rooted in established principles. GoogleTest is fundamentally based on the xUnit testing framework architecture.
So like GUnit for Java, GUnit for C#.
Exactly. It's the gold standard. So for any engineer coming from those environments, the whole pattern of setting up fixtures, running tests, tearing them down, it's all instantly familiar.
Which means less range-up time.
Way less. It's a battle-tested structure.
That familiarity is huge. Okay, what about the technical side? C++ moves fast. For anyone looking at the current stable branch release 1.110 byte xWin, what do they need to have?
This is a crucial detail. The 1.17 POC X branch requires you to use at least C++ 17.
Okay, so that's the minimum bar.
It is, and it tells you something important. It tells you Google is leveraging modern C++ features for performance and safety. They're not stuck supporting ancient legacy code bases.
That sets the bar. But to really get the scale of this project, you just have to glance at the GitHub metrics. This isn't just some internal tool anymore.
Not at all. It's a global reference point.
The numbers are massive.
Yeah.
We're talking 37.9 thousand stars and over 10.7 thousand forks.
And look at the contributors. 424 people have actively shaped this. That popularity means it's incredibly stable and mature. And the language breakdown, well, there's no ambiguity.
Let me guess. C++?
C++ is 89.5% of the repository. It is a dedicated first-class C++ tool through and through.
Okay, so let's translate that scale into utility for you, the developer listening. Why should you start using this today?
For me, the number one feature for just workflow speed has to be test discovery. Oh, absolutely. Think about that manual chore of having to register every single test you write.
Or updating some central index file every time. It's a pain.
It's a total pain point, and it's just gone. GoogleTest automatically finds and runs your tests. You just write the code and the test, and the framework handles the rest.
That cuts down on so much friction. And once it finds those tests, you have a lot of flexibility in how you run them right.
A ton. You can target individual tests, you can enforce a specific run order, or, and this is the big one for modern CI pipelines, you can run tests in parallel.
Which, when you're talking about enterprise scale C++, thousands of unit tests?
It's a necessity. It's not a luxury. That parallel execution is built right in, and it ensures your feedback loop is as fast as it can be. It saves days of development time over a project's lifecycle.
Okay, so we got the architecture, we've got the speed. But for a C++ powerhouse, the real magic has to be in the depth of the toolkit.
Yeah.
Beyond just a simple assertical, what really sets GoogleTest apart?
It's the depth of control you get. Yes, they provide a rich set of assertions out of the box for equality, inequality, exceptions, all the common stuff.
The usual suspects.
Right. But the truly professional-grade feature, the one that makes a huge difference in large code bases, is the support for user-defined assertions.
Okay, that sounds powerful. But tell me why a team should care about that. My first thought is that a bunch of custom macros could actually make a test suite harder for a new person to read.
That's a totally valid concern, and it really comes down to discipline. But think about a complex C++ project. You have custom data structures, you have domain-specific rules, right?
Sure.
Checking those things might take 5 or 10 lines of boilerplate code every single time. Instead of repeating that mess, you define one clear, highly readable custom assertion that wraps up all that complexity.
So you give it a meaningful name.
Exactly. And when you do that correctly, it makes the tests easier to understand, not harder. It improves readability and consistency across the whole codebase.
That makes a lot of sense for maintainability. Yeah. Now, the next feature the documentation mentions is probably the most surprising one for newcomers. Death tests.
Yeah. It sounds intense.
It really does. What is that?
It's critical for robust applications that handle serious errors. A death test is used to verify that code exits in a certain way.
So you're testing for failure.
You're testing for correct failure. You need this for error-handling code that's explicitly designed to terminate the program when it hits an unrecoverable state, like a seg fault, or a severe input validation error that has to halt everything.
Okay, so you're testing that it terminates cleanly when it's supposed to. But how does it do that without just crashing the entire test runner?
And that's the clever part. It doesn't run the failing code in the main test process. It spawns a child process, runs the test code there, and the main runner just checks the exit status of that isolated child.
That's smart. So your main test suite stays stable, even when you're deliberately testing catastrophic failures.
Exactly. It's really solid engineering.
And speaking of failures, GoogleTest gives you more granular control with this distinction between fatal and non-fatal failures.
Right. A fatal failure is what you'd normally expect. It stops the current test immediately because the state is just too broken to continue.
But a non-fatal failure.
That's different. It records the failure, but it allows the test to continue running to the end.
Oh, that's a huge time saver.
It's massive. It means you can catch multiple issues in a single test run without having to fix, rerun after every tiny error. You get a much more complete picture of the test's health in one pass.
That definitely helps with completeness. Let's talk about coverage. How does it help you efficiently hit all the corner cases? This is where parameterization comes in, and there are two types. Let's start with value parameterized tests.
Value parameterized tests are all about the inputs. They let you define your test logic just once and then run it multiple times with a whole list of different input values.
So for testing boundary conditions, like minimum, average, maximum values.
Perfect example. You write the test once, feed it those values, and it just runs. It cuts down on a huge amount of code duplication.
Okay, and the second type is type parameterized tests. If the first one handles different values, what's this one for?
This one handles different data types. It's absolutely crucial if you're testing template functions or generic code.
Things that need to work with ints and floats and custom objects.
Exactly. You write the test logic once, give it a list of types, and it runs the test for every single one. It gives you maximum coverage for generic algorithms with minimal test code.
That level of efficient coverage explains why a framework like this gets so much traction. And if it has this much depth, you expect it to be trusted by the biggest players.
Right.
Which brings us to real-world adoption. I mean, if Google uses it, who else is trusting this for really foundational mission-critical work?
The list is basically a who's who of major C++ projects. It establishes immense credibility.
Give us some of the highlights.
Well, top of the list, you have the Chromium projects. That's the open source foundation for the Chrome browser and Chrome OS. Then there's the LLVM compiler.
Wow, okay, so the toolchain itself. That's used by Apple, Sony, pretty much everyone.
It's a cornerstone of modern development, and within Google's sphere, it powers protocol buffers, their data format that is just everywhere. The docs also call out the OpenCV computer vision library,
Which is used in academia, robotics, industrial apps.
and that range is what's so impressive. It goes from low-level compiler infrastructure like LLVM all the way up to high-level image processing in OpenCV. It just shows how adaptable and robust the framework is.
And that kind of adoption always leads to a great ecosystem, which is just as important as the core features. The community builds extensions to make it even more powerful.
Right, to integrate it into every workflow you can imagine.
Let's talk about some of those.
Yeah.
Not everyone wants to live on the command line, right? The docs mention GR runners.
Exactly. For developers who want that immediate visual feedback, these are invaluable. You've got gtest runner, which is a Qt5-based GUI for Windows and Linux. And then there's GoogleTest UI, which is a C# runner with a progress bar and failure tracking.
The benefit being you don't have to scroll through a giant wall of text in your terminal to see what failed.
You get instant visual confirmation. It eliminates that context switch.
And if your main problem is speed, even beyond the native parallel execution, the community has a specialized tool called gtest-parallel.
Yeah, that's a test runner built specifically to execute tests concurrently. It can give you a really significant speed up, especially in some of those large, older build systems.
But for the daily workflow, the editor integrations are key.
Absolutely critical. The docs highlight VS Code extensions like the Google Test Adapter and C++ TestMate. These let you see your whole test suite in a tree view right inside your editor.
And you can run or debug with a single click.
That instant feedback loop is priceless. It keeps you in the flow state.
But the most advanced integration, the one that bridges business requirements and the actual code, has to be this thing called Cornichon.
Cornichon is fascinating. It connects testing directly to behavior-driven development, or BDD. It uses the Gherkin DSL parser.
That's the given when then language that business analysts use.
Precisely. It takes those requirements written in Gherkin and automatically generates the stub code for your GoogleTest tests.
That's a huge strategic advantage. It means the requirements aren't just in some document somewhere. They're physically driving the structure of your test from day one.
It closes that loop between stakeholders and developers, ensuring the implementation always aligns with what's expected.
Okay, last one. For big projects, standardization is everything.
Which brings us to reporting.
And that's handled by the gtest tap listener.
Right. This tool implements the Test Anything protocol, or TEP for a standardized output. And TAP is important because your main enterprise build runner, whether it's Jenkins or GitHub Actions or whatever, it understands TEP.
So this listener makes Google Test's results plug and play with the broader ecosystem.
Seamlessly. It's all machine readable.
So if we step back and summarize, Google Test is this incredibly mature, high-performance C++ framework. It's based on the xUnit architecture. It combines testing and mocking.
It offers next-level features, from user-defined assertions to death tests, and ensures incredible coverage with its parameterization.
And it's all trusted by massive foundational projects like Chromium and LLVM.
It really is the complete high-fidelity toolkit you need for modern C++ development, where complexity and scale are just the norm.
And as we close this deep dive out, we want to leave you with one final provocative thought that comes straight from the documentation's own announcements.
Oh, yeah.
We have a coming soon section, and there's a very interesting item on it. The plan to take a dependency on Absol.
Wow, okay. For anyone who doesn't know, Absol is Google's massive C++ utility library. It's full of foundational building blocks, advanced containers, concurrency primitives, all sorts of things.
Exactly. So just consider that for a second. The core testing framework, which we've just spent all this time saying is already incredibly powerful,
It handles mocking, death tests, all of it.
is now planning to integrate this foundational utility library. What fundamental shift or expansion does that signal?
It makes you wonder what deeper complexities of modern C++ they're preparing to tackle next. Is it about async operations? Or maybe highly complex data structures?
That integration is a huge signal about the future direction of C++ testing, something to mull on while you look up that primer.
Keep digging, and happy testing.